Hello, this video will cover magnetic particle inspection using a Magnaflux machine. We will be using a small block Chevy cylinder head to demonstrate how to check for cracks in a cast iron or steel component. A Magnaflux machine creates a magnetic field through the component, so it is important that the component is a ferrous material like cast iron or steel. The part that you wish to check is either going to be mounted in the tailstocks, or it can be supported on a set of blocks. It's a matter of whether you're going to use a coil shot or a head shot that determines which stand you're going to end up having to use. If we look at the controls down on the lower left-hand side, the first controller to your left is a tailstock control. That's going to control the air pressure. We're going to need at least 60 psi to adequately control the tailstock pneumatic ram. It is also important to note here that the toggle switch to the left should be in the retract position. This is so that when you switch from a head shot to coil shot, it will retract the ram. Let's take a look at the control panel here, starting with the left and working our way to the right. So to the left, you have the off button in red. To power on the machine, there is the on toggle. You'll push the on toggle down. That will turn on the power to the machine. Next, you have the black light. The black light toggle switch is to obviously turn the black light on and off. You will need to turn the black light on a few minutes before you want to start it. The black light bulb needs time to warm up. Next switch over is our pump switch. This pump is the pump that actually will circulate the magnetic particle solution. So we're going to want to turn that on a few minutes before we start as well, so that we can agitate the magnetic particles and get them mixed up into the solution. The next switch that you have is the fan switch. When you pull the head or the hood over to inspect, you are going to want to turn the fan on to get some airflow in there, or it's going to get a little bit warm from the black light and also uncomfortable. So the fan is in there to make the environment a little nicer. The next toggle switch that you have is a mag and demag switch. When you are going to magnetize the part in order for the magnetic particles to work, you will have the toggle switch in the upwards mag position. When you go to demagnetize a part, meaning that you want to eliminate the magnetic field, you will use the demag switch, which is down. That is so that you don't put a part back into service magnetized. That would not be good, because the magnetic particles that are suspended in the motor oil and stuff as you are running the vehicle will want to stick to your magnetized part, and that is going to cause increased wear. The next knob you'll see is the current knob, and next to it there is a scale showing how much current is being applied. We are going to start out at about 1,000 amps, and we will adjust our field coil strength from there based on a formula that is in the handbook for this machine, and we'll go over that in a little bit more detail in a little bit. The last thing that you'll see on the control panel on the far right hand side is two little red lights that will light up to indicate what position it's in. If you are in a head shot with the tailstock, you will have a red light indicating that you are performing a head shot. If you switch to a coil shot, then the red light will illuminate above the label that says coil. So let's go ahead and take a moment here to power on the machine and then turn on the pump for the magnetic particle solution. We'll also take a look down inside. You should be able to see the pump pumping the solution, and it should be agitating it as well, so that the magnetic particles are loose and floating in the fluid. Let's take a second here to show you how to adjust the tailstock. The tailstocks do slide back and forth on a set of rollers. There is a lever in the front that when it's pushed into the upward position will lock the tailstock down so that it does not move. You'll position both the left and the right hand side so that you can get your part to fit in between. Okay, we're going to go ahead and set this machine up for a headshot. I always like to start with a headshot first. So we're going to take our cylinder head, we're going to mount it on the little wooden pads. There's a little ledge on each of the tailstocks that you're going to try to set this on. And we're going to set the tailstock to the right as close as we can. Always the fun part here. And then we're going to lock it down. We are now going to want to step on the switch inside of the orange box. This will activate the pneumatic ram to lock the part in place and signal to the machine that we are going to conduct a headshot. We're going to lock the tailstock. This light's going to come on telling us that it's a headshot. This ram move forward, lock the piece in place. We're going to set our current. Now we're going to activate the field current. Okay, the next thing we need to talk about is when we are going to irrigate the part. The continuous method has us irrigate the part before we magnetize it. Then we apply the magnetic current and then apply the black light. This is used on low carbon material. The next method is known as the residual method, and it is used for higher carbon content materials. And so it requires that we magnetize the part, then irrigate the part with a solution, and then use a black light to check for the defect. And then we can check it with our black light again. So that will show up. When using a headshot, we will be looking for defects or cracks that are going to run parallel with the length of the material mounted between the tailstocks. A coil shot will look for cracks that will occur perpendicular to the length of the part being shown. And so we will use the tailstock control lever, which is the orange covered button, to release the pressure on the pneumatic ram. It will also select the machine to activate the coil. We will then mount the coil over the part that needs to be checked. It has a magnetic field size of about 18 inches, so you may need to perform a coil shot in 18-inch intervals in order to make sure that you introduce a magnetic field across the entire part. Again, this is going to identify defects that are perpendicular to the length of the part being checked. Okay, so now with the hood over us, creating a dark room, and a black light that is warmed up and ready, we can now thoroughly inspect the surface of the part to check for cracks. In this case, we have a crack between a water jacket and a head bolt hole on this small block Chevy. You can see it's in the middle of the screen. It's indicated by a greenish yellow fluorescence that is activated by the black light. At this point, you've conducted your inspection and hopefully did not find any cracks, but if you did, you now know that you'll need to take care of those. The last step is to demagnetize your part. And so to do that, you will need to select the mag to demag switch, put it into the demag position. You can then activate the current flow foot switch, and that will activate the process of running the field in reverse as to neutralize the magnetic field. Once the process is complete, you can use a Gauss meter like this one shown, and we are looking for minimal amounts of needle movement. If you see a large amount of needle movement, that would indicate that you still have a magnetic field, and you're going to want to repeat that process. And you are all done.